Lesson 16, more on modeling relationships with a line. Alright, let's go ahead and look at this. The curb weight of a car is the weight of the car without luggage or passengers. The table below shows the curb weights in hundreds of pounds and fuel efficiencies in miles per gallon of 5 compact cars. Using a calculator, the least square line for this data set was found to have the equation y is equal to 78 62/100 minus 1.5290x, where x is the curb weight in hundreds of pounds and y is the predicted fuel efficiency in miles per gallon. The scatter plot of this data set is shown below, and the least square lines is shown on the graph. You will calculate the residuals for the 5 points in the scatter plot. Before calculating the residual, look at the scatter plot. Alright? So examine the scatter plot. Alright, we're going to look at question number 1. Will the residual for the car whose curb weight is 25 and 33/100 be positive or negative? Alright, so let's look at this. Excuse me. So the car who has a curb weight is 25 and 33/100. So 25 and 33/100. Is it going to be positive or negative? Well, it's going to be positive because it is above the line. Now it says roughly what is the value of the residual. Alright? Well, it looks to be like 40 to 43. So roughly we're going to say 3. So it is going to be a positive residual. Alright? And then we're going to say that the value is about 3. Alright? Will the residual for the car whose curb weight is 27 and 79/100 be positive or negative? So we're going to go to 27 and 79/100, which I guess would be this one. Is it going to be positive or negative? Well, it looks to be negative because it is below our best fit line or our least squares line. And it wants to know roughly what's the value of that point. Well, it looks to be about, I would say from 31 to 37. So about -6. So it is a negative residual. Value is roughly -6. Alright? Alright, so now we're going to confirm this. Alright? The residuals for both of these curb weights are calculated as follows. Substitute x is equal to 25 and 33/100 into the equation of the least squares line to find the predicted fuel efficiency. And we get 39 and 9/10. Now calculate the residual. The actual value, which is 43 minus 39 and 9/10, is 3 and 1/10 miles per gallon. We said roughly 3. Alright, substitute 27 and 79/100 into the equation. We get 36 and 1/10. Now calculate the residual. Excuse me. The actual value was 30 minus 36 and 1/10 would be -6 and 1/10, and we said roughly -6. Alright. These two residuals have been written in the table below. Alright, so they've written them into the table. Alright, so Continue to think about the car weights and the fuel efficiencies. For example, 1. Calculate the remaining 3 residuals and write them in the table. Alright. So the first thing we have to do, excuse me, is we have to plug in the weight of our car to our equation. Alright, so I'm going to have to pick up my calculator because it has a glare. So 78 and 62 tenths, or 62 hundredths, minus 1.5290, and we're looking at 26 and 94 hundredths. So we get approximately 37.4. Alright, and the actual is 38. So that gives us a residual of 0 and 6 tenths. Alright, now we're going to do 30 and 12 hundredths. Alright, so 76 or 78.62 minus 1.5291 times 30 and 12 hundredths gives us approximately 32.6. So we're going to take our actual, which is 34, minus 32.6, which gives us a residual of 1.4. Alright, then we're going to do the last one. So 78.62 minus 1.5291 times 32 and 47 hundredths is equal to, that's equal to about 30, or I'm sorry, about 29, because I have 28.9701, so we'll round that to 29, and then 30 minus 29 is 1. Alright, so we've done that. Alright, so let's look at number 4. Suppose that a car has a curb weight in hundreds of pounds of 31. What does the least squares line predict for the fuel efficiency of this car? Alright, so if I plug that in, y is equal to 78.62 minus 1.5290 times 31. Entering that into the calculator, I get 31 and 2 tenths. Would you be surprised if the actual fuel efficiency of this car is 29 miles per gallon? Explain your answer. Alright, well, 29 minus 31 and 2 tenths would give me negative 2 and 2 tenths. So looking at our residuals range anywhere from 6 tenths to 3 and 1 tenth. So would that be surprising? No, it's within the range of our residuals. Alright, a residual plot is made by plotting the x values of the horizontal axis and the corresponding residuals on a vertical axis. Alright? So how do we make this? So here's what this would look like. Let's go ahead. It is often useful to make a graph of the residuals called a residual plot. You will make the residual plot for the compact car data set. place the original x variable, or the curb weight of this car, on the horizontal axis and the residual on the vertical axis. For this example, you need to draw a horizontal axis that goes from 25 to 32 and a vertical axis with a scale that includes the values of the residuals that you calculated. Next, plot the point for the first car. The curb weight of the first car is 25 and 33 hundredths, and the residual is 3 and 1/10. You're going to plot the point 25 and 33 hundredths and 3 and 1/10. Alright, so the axes in this first point are shown below. So I'm going to do 25 and 33 hundredths and 3 and 1/10. And I would plot a point. Alright, notice that this line is at 0. So it says plot the other 4 points. Alright, so we're going to look at 26 and 94 hundredths. So 26 and 94 hundredths was as close as 27. And the residual is 6/10. Alright, so I'm going to go up here and I'm going to plot a point about right here. Alright. The next one is 27 and 79 hundredths. 27 and 79 hundredths, and it's close to 28. And the residual is negative 6 and 1/10. So it's going to be like right here. Alright. Then we've got 30 and 12 hundredths. So 30 and 12 hundredths, that's not much above 30. And a residual of 1.4. So it's close to 2. Well, about middle of 2. Between 1 and 2. Alright, and then 32 and 47 hundredths. And I have a residual of 1. So we're going to plot it right there. Alright. Alright, so we've done that. How does the pattern of the points in the residual plot relate to the pattern in the original scatter plot? Well, let's go back to the original scatter plot. Look at my original scatter plot. Well, the first point in the scatter plot is a long way above the least squares line, and it's pretty far away from the, it has a large residual, so it's pretty far away from the 0 line. Alright, so my points seem to follow the same pattern. The same pattern on both graphs. Alright, because I see that the third point has a huge negative residual. Well, going over here to my residual plot, I have a huge negative residual. Alright? Alright guys, that's the lesson. Very simple lesson, very short lesson. Hope you have a great rest of the week, guys. We are almost finished.